Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about IR spectroscopy. In that we have seen one of the table which shows IR absorption band at particular functional groups. So details of it we have learned, and when there is a OH, NH or what we can call it as these are the group which generally shows IR absorption peaks in between 2500 to 3600 per centimeter. So that type of the if suppose there is a carbon-carbon triple bonds are present, either carbon-carbon triple bond or carbon-nitrogen triple bond, the IR absorption band appear around 2100 to 2250 per centimeter. It is known as a triple bond region, or the band appear around 1700 per centimeter is due to the presence of carbonyl group. The sum of the absorption band, the exact position of absorption depends on force constant, masses of the atom and environment of the bond. Or sometimes the band in IR spectra are slightly shifted due to the conjugation, hydrogen bonding and electron donating or electron withdrawing group. So that type of the information we have discussed in our previous lectures. So today what we are going to discuss, let's see here, characterization of IR absorption of some functional groups, which we have learned in our previous lecture, but characterization of IR absorption of some functional group that we are going to discuss. Let's begin with first one is a hydrocarbons. Let us see here is a hydrocarbons, that is the first one, hydrocarbons. As we know that hydrocarbons, the word clearly indicate that the organic compound which is made by carbon and hydrogen only is known as hydrocarbons. The organic compound belonging to such category, for example, alkane, alkynes, aromatic compound, for example, benzenes. So these are the compound belonging to these type of the compound. They are hydrocarbons because the name just I have mentioned here, like alkane, alkyne, alkenes, aromatic compound, all are the example of hydrocarbons because they are made up of carbon and hydrogen only. IR absorption spectrum of alkanes, alkenes, alkynes and aromatic hydrocarbons shows characteristic absorption bands due to stretching of carbon-carbon single bond and CH bonds. Let's see, first one is alkane. As we know that here alkane, and we know that alkane, the organic compound having the general formula CnH2n plus 2 is known as alkane, where n indicate as a number of carbon atom, and if you put the value of 1 in that, you will get the family of first member of the alkane, which is a methane molecule. If you put the value second 2, you will get ethane molecule, propane, butane, pentane, hexane, heptane, nonane, octane, decane. So these are the example of that alkanes. And now if you see here in a alkane, there is a carbon-carbon single bond is present, and therefore if you talk about the functional group, here is no functional group present in this alkane. The absorption band due to stretching of carbon-carbon single bond is very weak. Carbon-carbon single bond is very weak. That signal or that peak, or what we can call it as a signal or peak or band. These are the three synonym word you can use while discussing these IR spectroscopy. Single bond is very weak and generally appears in the region 1200 to 800 per centimeter, and these bands are not very useful for identification, as almost all organic compounds will show these peaks. Remember, these bands are not very useful for identification, as almost all organic compounds will show these peaks, because every organic compound it is made up of by carbon and hydrogen, and therefore every organic compound consists these type of the peaks due to the carbon-carbon single bond or carbon hydrogen. So every organic compound can show these peaks. So it is not useful as far as organic chemist point of view is concerned. Second one, let us see as a alkenes. Second one, B, which is known as a alkenes. And as we know that alkanes, this one is alkenes. And if you, what do you mean by the alkenes? Again, the organic compound having general formula CnH2n is known as a alkenes. In the alkenes, the last suffix ene clearly indicate that there is a presence of carbon-carbon double bond, which is a functional group present here. In above case, there will be no functional group, because carbon-carbon single bond and carbon hydrogen, these are the stretching frequency. Every organic compound shows these peaks, and therefore these peaks are not useful for the identification of, or for the interpretation of IR spectra. It is not useful as a organic chemist point of view. it is not useful. But here, if carbon-carbon double bonds are there, the peaks generally appear around 620 to 1618 per centimeter. This is generally obtained about the stretching frequency. This one is due to the stretching frequency. Stretching vibration frequency is observed if 1620 to 1680 per centimeter. These peaks clearly indicate that there is a presence of carbon-carbon double bond in the organic compound. Understood this one? This is a very clear-cut explanation here. The presence of the appearance of absorption peak at 1620 to 1680 per centimeter shows or indicate or suggests presence of carbon-carbon stretching frequency of alkenes. So this is a clear-cut information about that alkenes we can draw from this. The carbon-carbon double bond stretching frequency of unconjugated olefin absorbed near 1614 per centimeter. 1614 per centimeter. Disubstituted trans olefin absorbed near 1617 per centimeter, which is a trans, while cis olefin absorbed near 1650 per centimeter, which is due to the cis. However, these bands are not reliable because they disappear for symmetrical alkenes. If there is a symmetrical alkenes are present, as we know that if there is a symmetrical compounds are present, they are IR inactive, and therefore which is not the useful as a chemist point of view. But remember here the peak, the appearance of absorption peak around 1620 to 1618 per centimeter stretching frequency, which clearly indicate that or shows that the presence of carbon-carbon double bond stretching frequency of alkene. If the appearance of absorption peak around 1640 per centimeter indicate the presence of the carbon-carbon double bond in that compound, in the organic compound. If the peak appear around 1617 per centimeter, as we know that cis and trans are the geometrical isomers. Geometrical isomer means what? The restriction of rotation. The rotation of the bond is restricted due to the presence of carbon-carbon double bond, and the isomer gives rise to geometrical isomer. That is known as geometrical isomer. Geometrical isomer means the rotation is restricted due to the presence of carbon-carbon double bond is known as a geometrical isomer, and cis and the trans isomer are the geometrical isomer. Trans isomer, similar group are on the same side of the carbon-carbon double bond is termed as a cis isomer, whereas similar group are on the opposite side of the carbon-carbon double bond is said to be trans isomer. So that is there. If trans isomers, the peak appear around 16-17 per centimeter. If the cis olefin is the old name of that alkane, and that appear around 1650 per centimeter, clearly suggests that the presence of cis olefin present in the organic compound. Let's move on to the next one, which is third one, that is a alkynes. And as usual, similar to as a previous these two one, the general formula of alkyne is a CnH2n-2, which is the general formula of alkyne, and the simplest molecule of alkyne is a acetylene. And if there is the functional group present over there, carbon-carbon triple bond, which is a functional group, and as we know that IR radiation is known for getting the information about the functional group, and that's why we are studying the various functional group and their vibrational frequency or the stretching frequency at a particular region band clearly suggests that what kind of the functional groups are present in the organic compound. Within a few minutes we will get the information regarding that the spectra, and spectra can be analyzed by organic chemist or by training. Without the knowledge of chemistry, you cannot analyze, you cannot interpret the spectra. So it is needed the training. Generally, as an organic chemist can be identify, recognize the peak is due to what. So let's see here the general formula CnH2n-2, and acetylene, as we know that it is it containing as a carbon-carbon triple bond is an functional group. The band appear around 2100 per centimeter to 2500 per centimeter. This is known as a triple bond region, which we have seen during that general spectrum. We have divided in a different region, and the band around 2100 to 25 per centimeter, it is known as a triple bond region. Here either carbon-carbon triple bond or carbon-nitrogen triple bonds are present, and they give the peak, IR absorption peak around in between these, and therefore that region is generally known as triple bond region. That's it. The weak, here also the bands which appear is very weak. Carbon-carbon triple bond, the weak carbon-carbon triple bond stretching, the weak carbon-carbon triple stretching bands of acetylenic molecule occurs in the region of 2100 to 2260 per centimeter. Generally, here is shown as 2100 to 2250 per centimeter. Very weak signal is obtained or observed due to the presence of carbon-carbon triple bond. Because of symmetry, no carbon-carbon triple band is observed in the IR spectra for acetylene and other symmetrical alkynes. For monosubstituted alkynes, absorption occurs at 2100 to 2140 per centimeter, while for disubstituted alkynes, absorption occurs at 2190 to 2260 per centimeter. The carbon-carbon, in addition to this, suppose there is RC triple bond C, and this is a compound and it is a terminal alkyne. It will produce two distinct peaks. One is due to acetylenic CH tracing and one is due to carbon-carbon triple bond. And as we know that carbon-carbon triple bond found to be 2150 to 2250 per centimeter, this peak clearly suggests that the presence of carbon-carbon triple bond in that organic compound. In addition to that, the peak appear around 3300 per centimeter, clearly indicate that this peak is due to presence of acetylenic CH tracing, and these two peaks clearly indicate that or shows that the presence of terminal alkyne in the organic compounds. And so in this way we can clearly suppose, let us see over here one of the compounds, suppose CS3. So how will you, suppose question may appear in the exam, how will you distinguish the following pair by IR spectroscopy? Let us see here question. How will you distinguish the following pair, by IR spectroscopy? If such type of the question may appear in an exam, or suppose it would appear in an exam, how will you answer this? So here suppose as a first compound maybe as this one CS3, then CH2, C triple bond CH, and another would be this one CS3, C triple bond C, and CH3. These are the two compounds. They are isomers of each other. What kind of the isomer they are? Do you remember? This is a structural isomers, right? And structural isomer also further divided into 4 types. One, chain isomerism. Second one, position isomerism. Third one, functional group isomerism. Fourth one, metamerism, and fifth one, tautomerism. So these are the kind of the structural isomers, but out of that 5, what do you think this type of the isomer is a positional isomerism? Remember this one only. If you see here, if you observe these two structure carefully, what do you see? Here you will observe here, or you will observe here, the position of carbon-carbon triple bond is at a terminal position, but here the position of that carbon-carbon double bond is in between as a 2 and the 3 carbon atom. but here the triple bond is present at 1 and 2 carbon atom, and therefore only just by changing as a position of the carbon-carbon triple bond, and that's why it is belonging to the positional isomerism. Right now, how will you distinguish the following pair by IR spectroscopy? If you see here carefully, which is a functional group present in this compound, you can clearly see triple bond here also has a triple bond. Immediately the organic chemists know that there is a triple bond region, and triple bond, the band will appear. This molecule, if you suppose this molecule you put in a IR spectrophotometer, it will give the signal due to the presence of carbon-carbon triple bond is around 2150 per 50 or 2250 per centimeter, which clearly shows that there is a presence of carbon-carbon triple bond. And in this molecule also, but it is a symmetrical molecule. Let us see over here this presence of carbon-carbon triple bond, the 50 to 2250 per centimeter. This also, both the molecule give you the two peaks, and both the peaks are identical because both the molecule containing same functional group, and therefore they will produce the same signal. The peak will appear around at a same absorption, so we cannot distinguish these from each other. But in addition to that, the molecule, the compound one, there is a two peaks could be seen in the structure 2, because one is due to the carbon-carbon triple bond and one is due to the acetylenic CH, which is around 3300 per centimeter. But in this particular, the recognizable peak only one observed in a structure second, whereas in a compound first there is a two recognizable peak or notable peak observed in a structure number first, and therefore by giving such type of the peaks, you can clearly distinguish these two pairs by IR spectroscopy. You just mention the approximate values of that particular functional group. So this is the way of explanation. This is the way of explanation of such a type of the questions. Do you remember this? Okay, let it be next one. So the carbon-carbon triple bond stretching band of monosubstituted alkynes occur in the range 32672 to 3330 per centimeter. The triple bond CH bonding vibration of monosubstituted alkynes occur at 610 to 1700 per centimeter. So there is a one. Now is a aromatic compound. Let us discuss here aromatic carbon-carbon double bond. So we are talking about these hydrocarbons, and what do you mean by the hydrocarbons? Under that heading we are discussing, these are the various terms A, B, C, and now is a D, that is aromatic hydrocarbons. And as we know that in the aromatic, carbon-carbon double bond also present. Here in alkene also carbon-carbon double bond present, and in aromatic there is also as a carbon-carbon double bond. And as we know that these all are the aliphatic compound, this is aromatic compound. Theoretically, those organic compound obey or follow Huckel's rules are termed as aromatic compound, those are not obeying that rule, they are termed as aliphatic compound. So this is the way of distinguishing aromatic compound from aliphatic compound. Now, in alkene, there is a carbon-carbon double bond. In aromatic compound, also containing as a carbon-carbon double bond, carbon-carbon touching frequency we have seen. In case of the alkene, it is appear around 1620 to 1680 per centimeter. But here, if aromatic compounds are present, the stretching vibration frequencies appear around 1500 to 1600 per centimeter. This is a very important peak or the prominent peak observed due to the presence of aromatic carbon-carbon double bond. So this is the carbon-carbon double bond stretching frequency in the range 1500 to 1600 per centimeter is a characteristic of aromatic compound. It is a very characteristic, or we can call it as a prominent peak or the significant peak observed around 1500 to 1600 per centimeter clearly indicate that presence of aromatic compound in the organic compound. The double bond CH stretching bond occurs in the range 1300 to 3000 to 3100 per centimeter, while double bond CH bending band occurs in the range 675 to 610 710 per centimeter, and 3 to 4 bands in the region 1500 to 1600 per centimeter is a characteristic of aromatic compound. Let's see. So these are the, and generally what kind of the spectra they are producing, that the spectra IR actual spectra we will discuss in our next lecture. So I think these are the hydrocarbon which we have discussed here. The remaining thing we will discuss in our next lecture. I think with this let us stop today here. Have a nice day. Thank you.